All right, welcome. In this explainer, we're diving straight into what is, without a doubt, the single most important tool for any ethical hacker, Linux. You see, it's the engine that powers pretty much the entire digital world. And if you want to secure it, you've got to understand it first. So, have you ever wondered why hackers in the movies are always staring at that black screen with a glowing green text? You know the one I'm talking about. Well, turns out it's not just for Hollywood drama. That screen is the command line, and it is the literal gateway to having real power and control over a system. Let's dig into why that is. So, what exactly is Linux? You're probably using Windows or Mac OS on your computer right now, right? Well, think of Linux as the unsung hero, the powerhouse that's running silently in the background of almost everything else. It's the engine under the hood for most of the internet servers, your smart TV, even your Android phone. And the reason it's everywhere is because it's built from the ground up for stability, transparency, and, this is the big one, control. And for anyone in cybersecurity, control is everything. It's the whole game. Linux gives you that control at every single level. I mean, you can customize pretty much anything you want. And because it's open source, anyone can look at the code. That transparency is a huge security boost. Plus, since it runs most of the world's servers, if you know Linux, you understand the very battlefield you'll be working on, whether you're defending it or, ethically attacking it. Okay, so to master this new world, the very first thing you need is a map. And in Linux, that map is the file system. Think of it like this. Everything, and I mean everything, starts at the root, which is just that single /. From there, it all branches out. So you've got your personal stuff living in /home. The actual tools and commands you use, those are in /bin. And all those super important system settings are tucked away in a place called /etc. These are the main landmarks you absolutely need to know. So, what's the first thing you do when you open any map? You look for that little red dot that says, "You are here," right? Well, in Linux, we have a command for that. It's pwd, and that stands for Print Working Directory. It is the simplest, quickest way to figure out your exact location on that file system map we just talked about. And here's what that looks like in action. It's super simple. You just type pwd, hit enter, and boom, the system tells you your full path. So right here, you can see it's telling us we're currently inside the hacker folder, which is located inside the /home directory. See? Simple, immediate, and absolutely crucial for getting around. Okay, so you know where you are. What's next? Well, you're going to want to see what's around you, right? For that, we use the ls command. It's just short for list. You can think of it as literally opening your eyes and looking around the room you're in to see all the files and folders sitting there. And check out the output. You type ls and bam, the system just lays it all out for you. It shows us we've got a couple of folders here, documents and tools, and also a file named notes.txt. So just like that, we've gone from just knowing our location to having a full inventory of everything in it. All right, knowing where you are and seeing what's there is great, but you can't get much done standing still. You need to be able to move, and that's where the cd command comes in. CD stands for Change Directory, and this is basically your teleportation device for moving from one spot to another on that map. So let's try it out. If we type cd tools, we're telling the system, hey, move me from where I am right now into that tools directory. And just like that, we've traveled. Seriously, if we ran our pwd command again right now, you'd see the output is now home/hacker/tools. We're in a good place. Okay, so we can move around now. What's next? Interacting with the world around us. And these next few commands are your fundamental building blocks. You've got touch, which lets you create a brand new empty file just out of thin air. Then there's mkdir, that's make directory, for creating new folders. And finally, rm, which is short for remove, lets you delete files, create, organize, and destroy. Just look at how fast and efficient this is. One command, touchreport.txt, and a file exists. Another command, rmreport.txt, and it is instantly gone, forever. There's no pop-up asking, are you sure? There's no recycling bin to go rescue it from. This is that raw, unfiltered control we talked about. It's what makes the command line so incredibly powerful, and it's also why it demands your complete attention. So, we can get around, we can make stuff, we can delete stuff. But, hold on, who's actually allowed to do all this? And that question brings us to one of the most critical ideas in all of Linux and cybersecurity, permissions. You should really think of these as the keys to every single file and folder in the entire kingdom. See, every single file in Linux has a set of rules attached to it. It's really simple. It's broken down into just 3 basic actions: read, write, and execute. Read means you can see what's inside the file. Write means you can change it. And execute means you can run it, like a program. These 3 little letters, RWX, are the fundamental security layer for the entire operating system. So, who gets to decide who has these keys? Well, you've got 2 main types of users. There's you, the normal user, operating with safety rails on. And then there's root. Root is the super user, the system administrator, the king, the god of the machine. The root user has a key to every single door and has the power to do absolutely anything they want. Now, here's the really crucial part. You never want to be logged in as root all the time. It is just way too dangerous. One tiny typo, one wrong command, and you could literally wipe out the entire system. So instead, we use a special command called sudo. It stands for super user do, and it's basically like asking politely, hey, can I just borrow the master key for this one specific task? It's the safe, responsible way to use all that power. Okay, let's recap. We can navigate the map. We understand who holds the keys. Now let's put all these pieces together and see how we can take real control of the system. And while we're at it, let's look at one of the single biggest security risks that comes with all this power. So what's a process? It's just a fancy word for any program that's currently running. And on Linux, you have total visibility. There's a command, PSAUX, that's like the Windows Task Manager, but on steroids. It shows you every single thing running on the system. And if you see something you don't like or something that's misbehaving, you use the kill command to stop it instantly. Okay, time for the really important security lesson. We've been talking about permissions being like keys, right? So let me ask you a question. What do you think happens when you leave the keys to your most important, most critical file just lying around for anyone to pick up? What you're looking at here is a classic, incredibly simple, and yet absolutely devastating security mistake. There's a permission setting known as 777, which basically means read, write, and execute for everyone. It's the digital equivalent of leaving the front door to the bank vault wide open with a sign that says help yourself. An attacker doesn't need to be clever. They don't need to break any locks. They can just walk right in, replace an important file with their own malicious code, and then they just wait. And the very next time a user or the system runs that file, it's not running the real program anymore. It's running the attacker's code. And just like that, it's game over. And all of this really brings us back to that famous saying, right? With great power comes great responsibility. The Linux command line gives you immense power. The power to create, to destroy, to control a computer at its most basic level. But with that power comes a huge responsibility. Understanding how things break is only half the job. Knowing how to use that knowledge ethically, well, that's what really counts. So there you have it, the absolute fundamentals. You've been given a map, you've learned how to get around, and now you understand the keys to the kingdom. This knowledge is a seriously powerful tool. And just like any tool, its ultimate purpose, whether it's used to build and protect or to break and destroy, that choice is left entirely up to you. Thanks for watching.